when you've started. Thank you. Okay, so I want to begin by respectfully acknowledging those whose ancestral homelands I live and work on, the Ramaytush of San Francisco, and the Coast Miwok and Southern Pomo, where RFO is located. I also honor the traditional custodians of the land where some of you may be calling in from by Zoom. I also want to take a minute to honor all ancestors, past and present, of the peoples I've mentioned already, as well as our community here. Because of the week we happen to be in, and because I personally love learning about global calendars, I want to take a minute to acknowledge the special new moon of last weekend, which is a celebration of the Lunar New Year. It is the year of the rabbit, and the rabbit years are supposed to bring us peace and hope. I don't know about you, but I am ready for those things. So again, a happy Lunar New Year to everyone, and especially to those who honor this celebration. I want to amplify what Stephanie has brought up already, which is the partnership between USF, which is shown here on the left, and RFO, which many of you know is this beautiful structure on the right, nestled in the beautiful hills of Sugarloaf Ridge State Park in Sonoma. This is a relatively new partnership. There's a long story about how our RC20, our 20-inch optical telescope, the robotic mount dome, and CCD cameras, and a lot of filters and equipment languished in storage for years while we tried vainly to fight recession after recession to build a campus observatory. But just about a year and a bit before the pandemic, we decided this is it. This telescope needs to be used. I interviewed a number of local institutions and departments and was far and away blown away by the number one choice, which we ended up with, which was RFO. I know we're living through perilous times economically, but I'm so grateful that many of you are supporting RFO morally and financially, because these are tough times for nonprofits. And we are so happy with how they are training student docents and leaders of the future, how much research and outreach is happening, and they are bringing the skies to everyone, not just the Sonoma community, but just such a large community. So we are grateful. This is our 20-inch telescope, and I just wanted to put that up there for a minute because, again, we are so happy to finally see it being used and to know that it's being utilized by the community for research and outreach. We've had our share of drama with the relatively new fire seasons in California. Soon after we moved the scopes in, there were the devastating fires of 27 and 2018. And then, of course, soon after, the pandemic hit. So we are really looking forward to building a new era of just partnering with observations, research, and student outreach and community building between USF and RFO. We're really not that far apart, just a little over an hour. But we've really had our share of drama even before the pandemic with just everything going on in California. So I want to begin the talk by sharing that our view of space is changing. Here's the James Webb on that glorious Christmas day a year and a bit ago, launching and leaving Earth and looking back as it left behind different, as it left behind increasing parts of its payload and then went off into space. You can easily find little videos. This little dot here is the James Webb Telescope at L2 Lagrange point 2. If you want to ask me in Q&A why we put it there, I can talk about that, but it's orbiting there and you can see it going back and forth. So our view of space is changing, and the converse process, our view of who we are in relationship to what we put out there in space is changing as well. When we look up and we see things up there that we've put up there, as well as worlds on which we are now increasingly going to be planning to land, build bases, it changes our relationship with the cosmos and also how we see ourselves in place in the cosmos. And it's hard not to feel excited about space exploration, right? These are satellite streaks and astronomical images, and I want to fully own for a minute the irony of me talking about all the things to consider and worry about with satellite constellations when I know that RFO is on SpaceX's wait list. And we want internet for everyone, including RFO. That's not the issue. The issue is the pace at which it's unfolding and all the consequences that are not being assessed as a condition of licensing. So on the left here is an image that's only a week old. This is the SpaceX Falcon Heavy craft in a test flight. It had a triple core booster, and these two little side cores do a little maneuver when they, it's called the back boost burn. And basically they do a little maneuver while the main booster core helps the rocket propel ahead. But it's essentially to alter its trajectory to parabolic from a straight up. And these are exciting times. This is the re-entry of the Orion capsule, part of the Artemis mission series from NASA, re-entering Earth on December 11th, just last month, after a glorious 25-day sojourn around the moon, going farther than really anybody's gone from Earth into space, just a little bit beyond the moon. But so we're living in exciting times. And we know now, increasing certainty, that we're going to the moon. More and more countries are attempting to get there and land. And the goal is to have a lunar base within the decade. And I love this little, this image taken by another astrophotographer, not me, but this was that beautiful conjunction of Mars with the moon just about a month and a half ago. But I love this image because every time I think about how we're going to the moon, we know that it's basically a stepping stone to getting to Mars and beyond. So we're living in exciting times, but also perilous times. There's a lot of excitement with discovery. And I wanted to say this explicitly. And here's this one of the gorgeous early images from James Webb. Because as we barrel out into space, there's more than just our excitement and our innate love of exploration as a species. Space is our shared heritage and our shared ancestor. Whether we look at it as astrophysicists, where we say, oh, I know all my atoms have been through stars and supernovae, and I know exactly what kind of supernova the gold in my ring came from, and I know what kind of star the calcium in my teeth or the magnesium in my kale salad that I had for lunch. I know where all this came from. Sure, that's one way of looking at it, but for so many cultures, space is a cultural and spiritual ancestor. And we don't need to divide it up into science versus culture. In all the ways that we relate to space, it is our shared heritage, whether it's science, culture, art, storytelling, so very many ways that we relate to space. This seems especially important to me personally, just given the juncture of history we're at, where we begin to assess anew what is heritage and what is ancestry, really. Because particularly where we live in California and where the world is at, we've seen a lot of loss of habitat. I think of the redwoods as elders, and we've lost so many to fires and fire seasons. I personally also mourn the loss of Arecibo as an elder telescope. It was such a terrible year, 2020, and Arecibo was that last little gut punch at the end of a terrible year when it collapsed. And I need not tell you about all the elders lost to the COVID pandemic. But when we begin to look at space as an environment, we can't help but pair it in our minds with the extraordinary and accelerating impact of climate change. In the lower right is the foreign minister of Tuvalu speaking at COP26 a year and a quarter ago, where he said, we are sinking. I mean, he made a point about the rising waters and that their island is sinking. And he said, we need mitigating solutions now. So As much as we preserve and defend the planet by declaring areas of the world dark sky protection. In fact, I want to take a minute to honor the dark sky nations, the first being on the cut in the north of the Grand Canyon, the Kaiba Paiute Dark Sky Nation. It was first recognized in 2015. And the next one really was the island of Niue, oops, I'm sorry about that. The island of Niue, another dark sky nation that was designated in, believe it or not, March 2020. But the protection for land, sea, and sky can only go so far given climate change if the ocean itself is rising. And now, if we're facing pollution from the ocean above us as well, light pollution, falling debris, by the way, it's already happening. Rocket parts are falling out of the sky, and it will only get worse unless we do something. All of these protections can only go so far. And by the way, this island of Niue is just a hop, skip, and jump across the South Pacific from where Tuvalu's foreign minister spoke. So again, these issues are really very related. So in my perspective, there are a lot of existential crises right now. And I don't know about you, but I think a lot of us are feeling crisis fatigue. Like, how much bad news can we really listen to? It's all going downhill seemingly if all we did was read the major headlines. But I think we are called on at this crossroads that we face to reimagine the way we're doing science and space exploration. Because there are some things that belong to all of us. And in my opinion, the broadest constituency in near Earth space is humanity. It's not astronomers, it's not this group, it's not the military, it's humanity. So we need to consult all the constituencies and honor that we approach space in many, many different ways, and they all matter. They all matter. This is when the Polynesian Wayfinding Society and Voyagers came through the Bay Area a few years ago, and here's one of the SpaceX Falcon Heavy launches. I think we are a species that loves exploration. And I think there's a way to do this in new ways that aren't so much in a rush, in a relational way, in an ethical way, so that we can co-create from all human ways of knowing for our shared journey through space. Like I said, we relate to space through many, many human endeavors, whether we write, whether we sing, whether we storytell, whether we create a piece of art, whether we model galaxies like I do. So space really invites our integrative selves, and it deserves integrative solutions. So let me move on to the heart of my talk today, although really each of these slides is a standalone talk that I've given, but I just wanted to leave you with an overview, and I'll share recent updates as the slides go by. So what's going on in orbital space? Why is there so much noise being made about it right now? Until quite recently, we had only a few dozen, maybe a few hundred satellites in space. I mean, the original Iridium satellites accomplished a lot, and that was just a few dozen of them, and then eventually a population of a few hundred built up. The problem is they were in higher orbits, so their latency, meaning it takes a while for the signal to go up and come down, their latency was not actually something that served people's growing digital and broadband needs. So the idea of having more and more satellites in low Earth orbit, a few hundred to 1,200 kilometers above us, is something that's gained traction in the last few years, and it really burst on the global scene in May 2019. And in a video that I'll show you at the end, with the first SpaceX launch of 60 satellites, that satellite train was seen and commented on worldwide. And the number of satellites that are being approved for launch and are planned for launch is growing dramatically. 2023 is the year when this is going to grow dramatically by up to maybe a factor of 5 or 10 by 2030. And for many astronomers, these are actual exposures of comet Neowise from summer 2020. This is from the Chilean telescopes, Terra Tololo. But again, they were a problem 2 years ago with ruining astronomy exposures. But it's not just individual satellite streaks. The numbers that are planned will lead potentially to just the aggregate of them will lead to an aggregate effect of debris, a rise in global sky brightness, meaning you can't get away from it anywhere in the world. It could wash out the Milky Way, meteor showers, and much more, impacting a wide range of constituencies that I've listed here, much more beyond professional astronomers just trying to, publish their dissertation results or their postdoctoral results. This is about the health of entire ecosystems and the planet. And I want to honor that the gains from space-based internet are real. The pandemic revealed to us that broadband is basic necessary utility and that the digital divide is real. It's real. So the lofty rhetoric actually has some, I would say, positives behind it from these space industry companies, the democratization of space, access for all. But there's a lot of potential losses of something that are long-term in something that belongs to all of us. So here's a little video that I'll just show you a minute off. This video is already too old. There's already way more than this plan. This number is right now a little over 500,000, primarily because OneWeb and other companies have just gotten approved through Rwanda's launching sites, 330,000 satellites. So hundreds of thousands of satellites approved. So as you can see, it's going to quickly become even more of a metal cage than it is at present. And I can tell you, because we do briefings all the time to branches of the federal government, to the FCC, the FAA, it is already crazy getting in and out. And then, of course, you get these one-off events, like the Russian ASAT test, which creates a debris field for centuries. It is complicated. There's already huge numbers of course corrections from the space station and a number of SpaceX satellites up there already. They're already having to correct about it, correct for all the debris up there. And that's at a few percent of what's planned. So what are we doing about all this as astronomers? We organized a series of conferences that I've listed here. The one I was most closely involved with was SatCon 2, the second of the satellite constellation workshops, but I draw to your attention the two Dark and Quiet Skies conferences. This issue, since it burst on the global radar in May 2019, has really grown on people's awareness horizon. Everybody's writing about it, everybody's talking about it. There were, in this particular workshop that I was involved with, 4 working groups, but the one that I chaired with James Lowenthal of Smith College was the Community Engagement Working Group. This was the first time we actually brought communities in. It was always closed meetings between astronomers and industry, but we brought in communities for the first time, and we were very nervous. We didn't know how it would go, but after hundreds of hours of deep listening and lots of conversations, we were so proud and grateful for how things went. We got a whole day at the conference, and it was really wonderful. So here's a list of 22 working group members in community engagement for SatCon 2. We spanned every single time zone in the world, but we had 8 Indigenous, Native American, and global Indigenous culture team members, and we learned so much from them, not the least of which from our international partners were there is still no evidence that satellite-based internet is going to be an economic model that works. Will it be profitable for the companies? And the rates still haven't come down enough globally for it to be affordable in most countries. So that's something that we have to wait and see and hope that in the process, we don't leave hardware up there permanently while we figure out, is this economically feasible? So what is the problem with the satellites? What are the issues? Well, for 20 years, we've been building towards next generation observatories that are going to revolutionize astronomy. And here I'll focus for the next slide or two, and my gratitude to my dear friend and collaborator, Meredith Rawls, at the University of Washington, Seattle, who has shared a little information for these next two slides. The Rubin Observatory will come online in a few years, and it is going to be the best long-term, decade-long high-res color movie of the sky. It is going to be a broad, deep survey, and it's going to have unimaginable amounts of data. And the software pipeline has been in development for years, but like most superheroes in DC or Marvel movies, the greatest potential has become its greatest vulnerability, in particular because of the way it's designed to look at the sky. And the Rubin Observatory is not alone in this. It's a lot of next-gen observatories coming online. These data end up being extraordinarily vulnerable to satellite streaks and what's happening in low Earth orbital space. So here are some of the problems, but I'll go over just a handful of them. Again, I could speak for a full half hour just on this. Some of the problems are that when the satellites are first launched, they're very visible low in the horizon near twilight. Now, you might have seen all the headlines about the new Blue Walker 3 satellite, which was brighter than 99% of stars. It was just one, but it was very visible in the low twilight skies last month, and it prompted a lot of global headlines, and hoping that they'll fix that and not have it be so bright. Most satellites get a little dimmer as they then climb to higher orbits. But the problem is that as they climb to higher orbits, they end up staying up for longer in the night sky. And instead of getting, darkened when they pass through the Earth's shadow, they end up being illuminated all night long as they climb higher. And like I said, the impacts are worst for these kinds of ground-based telescopes, including the Rubin Observatory. But there's a lot of other problems. And in fact, this has become an extraordinary latitude-specific problem. Like Canada has its own protocols and documents it's rising, because it turns out that at middle level latitudes like Canada or in the Southern Hemisphere, other countries, it's actually becoming the worst for them. So it's very hard. We don't always have a good sense of satellite trajectories. How do we keep track of all this? So astronomers have been working closely with industry. And I have to say, SpaceX, OneWeb, and a number of industry partners have been very communicative and amenable to what we suggest, but they move so much faster, you see. By the time in academia that astronomers convene a committee to consider developing a working group to think about this, industry has already completely redone their satellites and launched a couple of thousand more satellites. So we have a timescale mismatch, but the collaborations are there. But one concern with focusing on just satellite streaks and darkening the satellites is a big step. One concern is it doesn't potentially factor in the potential aggregate effect, that rise in global sky brightness that I talked about. And the other thing is we have a few satellite companies that right now are the major players, and they've been amenable to working with us. They haven't quite reached our wish list magnitude, but more and more space actors and developing nations are coming on the scene, as they should. It's a huge potential for economic development, education, and medicine for a lot of developing nations. However, this is just not sustainable, and not everyone is going to work with astronomers. So we don't know where this is going. So my thanks to the space industry colleagues who shared this slide with me. This slide shows, and I'm very sorry, astronomers always have backwards scale. The lower number in magnitudes is actually brighter. The higher numbers is fainter. So the typical human eye, the dimmest it can see is about visual magnitude of 6. So what we really want the satellite operators to aim for is a target magnitude of 7. Now, when we gave them this list in fall of 2019, they turned it around in months. The problem is the coatings they were putting on, which reduced the brightness in optical, made them glow a lot more at infrared or heat energies, which was now interfering with microwave background and other observatories. Also, frequencies are being jammed by satellite communications. That's a whole other thing of radio and other interference. And lately, the satellites have been getting brighter again. Blue Walker 3 is but one example. So it's concerning. It's really concerning. I want to point you to this headline that's just a few hours old today, which is that SpaceX and the National Science Foundation have come to a new agreement regarding this darkening agreement. Again, this is a good thing, but this is one company in what's now becoming a very crowded arena. So we are not sure how to proceed from here, except slowly and intentionally. Now, here's a number by decade of the number of satellites per year. And as you can see, there was a time when it was a few dozen or a few hundred, but already by late 2020, it was skyrocketing. And in fact, we can really see a dramatic rise from SpaceX alone. But every now and then there's a weapons test or a collision of satellites or a rogue action, like I said, a weapons or an ASAT test, which then creates a debris field for centuries. So this is quickly becoming a game of whack-a-mole, but there's a real aspect of roulette to it too. I mean, the space station with people in it had to, after the Russian ASAT test in November 2021, had to do an enormous number of dodging maneuvers just to avoid hitting this debris field. And it's just not safe. It's just not safe. So we have a paper that's being considered for publication in Nature Astronomy, where we actually calculate out the impact of this growing satellite population in orbital space. Something that not everyone is aware of is that there's a broad range in debris size. So there's big debris, there's mid-sized debris, and then there's the kind of like fine grained sand, which is not very well constrained. But every log, meaning every factor or decade in debris size, actually contribute about the same amount of night sky radiance. So we don't just have to be worried about the big pieces. A sort of quiet ocean of small reflective particles wreaks just as much havoc. And the problem is, as it gets crowded up there, you're going to have a lot more collisions and debris generating events. We actually calculated from the rise in night sky brightness, the loss of astronomical data, and also the increased integration time needed because the sky brightness is going up. So this will not only diminish opportunities for ground-based discoveries, because let's face it, we can't put everything at L2 like James Webb, but it also increases the integration time, which means you just can't have as many science targets per cycle. There's a real dollar cost to this for the loss of data and science projects. And again, there's a whole environmental ecological aspect to this that you could ask me about in Q&A, but it's huge. The next couple of slides, I'm just going to flash at you, come back to it in Q&A if you want. We've done an enormous amount of briefings, most recently with the Office of Space Commerce, the Department of Defense. We got to present to the OSTP, the Office of Science and Technology Policy, aka Biden's Science Cabinet. They listened. Everyone listens. The problem is that there's no one office that centralizes operations of orbital space and where everyone has to go to for licensing. Right now, it's a free-for-all. There's no one agency in charge. And in my mind, industry is kind of gaming that a little bit while they can. But the language of the Outer Space Treaty, sure, it's over 60 years old. I'm sorry, over 50 years old, but it's still so relevant. And one of them is that space is a global commons. And all countries that are signatories to that treaty, which is many, this is binding under international law. So we need to fall back on treaties, even the older ones, because the language is already in there. Something else for Q&A and something else that we've been advocating for strongly. We've greatly expanded our advocacy circle. We've gotten the Sierra Club to sign off on a lot of what we're doing. And right now, a lot of environmental groups have joined grassroots dark skies group like the International Dark Sky Association to sue different branches of licensing agencies to say, stop, we need to slow down. This is becoming an environmental disaster, and we're not even at full capacity yet that's planned. So there's three aspects of this that I want to draw to your attention. It's not just when they're up there, right, which is what everyone's focused on, the streaks and so on, and the debris. It's also at the launch sites. There's enormous light, noise, and air pollution. And in the deorbiting phase, all that hardware has to go somewhere. When it burns up in our atmosphere, it's already increased metal oxide deposits that are having a very harmful effect. And if they go in the ocean, that's even worse. I mean, imagine putting 100,000 satellites in the ocean. I think in addition to these scientific concerns, something we've really been advocating for is to reimagine heritage. We have done presentations to various groups and branches of the United Nations where the UN has a lot of designated UNESCO World Heritage sites, Machu Picchu, cities, temples, and so on, boot prints on the moon. But we have really been advocating for viewing the heritage value of space, not just landing sites and boot prints, those are important, but to see that space has value itself as heritage. Dark skies is our heritage. Some countries like New Zealand, a very active but pretty new space sector, has signed the Artemis Accords with the US, but only under principles of indigenous Maori principles of stewardship and sustainability. So reimagining what heritage means, it could be not just the tangibles, but the intangibles of dark skies, space itself, and the environments before we arrive there. We are trying to get people to acknowledge and put that into their language. And because the industry is in a rush, this is the Artemis mission on the launch pad of NASA before it took off last fall. Industry is in a rush, and although we don't like to rush things, we are having to rush things as well because we need to protect space. As some of you know, I work deeply with a number of global indigenous communities. Most recently, I have returned from a transformative 10-day trip in the Guatemala highlands with Maya calendar keepers, Quiche Maya, who taught me so much. I've also worked with the Maori in New Zealand, as well as a large number of North American, Native American tribes. But on this slide, I want to express my gratitude to a broad circle of wayfinders spanning 10,000 miles of Oceania, ranging from the South Pacific to Sarawal, Guam, Hawaii, and many other islands and nations across the greater Oceania. They have noticed for years during wayfinding journeys the rise of satellites. So why is this a problem for wayfinding? Well, unlike astronomical observations where you can back correct with filters or software for satellite streaks, cultural sky traditions, including wayfinding, are real-time observations of the skies. So it interferes in real time. And as I pointed out to you, satellite constellations are very visible in the ground, especially low in the sky and close to the horizon. They're very bright. Why is that a problem? Because wayfinding uses horizon markers and a web of guiding stars in their non-instrument celestial navigation. The Southern Cross is an important one. but also the rise in global sky brightness that's predicted is going to impact the visibility of some of the most important constellations for wayfinding. So I wish to express my gratitude to the Circle of Wayfinders, Ohana wa mahalo. I want to wind down and open up the floor in just a handful of minutes for questions, but I want to say one of the privileges, endless fascinations, and teeth gnashing frustrations of working in this field is that it's 12 different fields, really. It's about as interdisciplinary as it gets. If you're not on the phone with an environmentalist, you're on the phone with a tribal leader, or you're on the phone with a space lawyer or a staffer who works for a senator. It's a gift, but it's also terribly hard because you often get ping-ponged around. Oh, that's not my, that's not my, arena. Go to this office, go to that office. By the way, I didn't even know space lawyers exist, but now I'm talking to them. I didn't even know that was a thing. So cast your mind over this. We are facing such a fascinating legal policy landscape. It's a wonderful opportunity. We are really struggling with where to even start. So I've listed a huge number of issues, as we literally occupy space. And don't forget, a lot of the leaders in the space industry are also owners of communication channels. I don't need to tell you, San Francisco's taken it on the chin from a certain recent owner of a communication channel. But I want to point out a lot of the space industry leaders are also involved with these other endeavors. And one sobering comparison point when we ask, well, all this is happening in space, but who'll be left holding the bill if satellite internet doesn't work out? And I think cryptocurrency offers a sobering comparison point where an unregulated industry went for it, and the average, investor was left holding the bill. So we don't want to be left with that environmental bill in orbital space. I've also listed a fascinating range of legal policy issues that have no clarification right now. Nobody knows where Earth ends and space begins. Nobody knows how crown nations like Canada and New Zealand, who are launching a lot of satellites, are going to honor treaties with sovereign indigenous nations within their countries, including treaties about mining, because space mining is a big thing. So we need creative solutions. I've also really listed like another huge list of issues, including environmental impact and mining. We're always so concerned about what can the environments do for us, but we never ask, how do we change the environments we visit, right? Study after study has shown that even airless worlds like the moon and Mars retain exhaust gases for months, if not years, from landing and taking off. So these are things to think about. Whenever I do an interdisciplinary presentation, one of the leading questions is, sure, NASA has a chief scientific officer and a chief financial officer, but who is the chief ethical officer of NASA? And my answer is usually, yeah, who is that? So I'll end with that initial train on May 24th, 2019, which happens to be my younger son's birthday. This was the satellite train that brought it to the global awareness from SpaceX, 60 satellites that went by. And it really began to ask the question of the night skies are transforming right now in real time. Dark skies are a basic human right. And what is this going to look like in a few years? Because it's going to be hard for future generations to value what they don't know. If you've never known the side of the Milky Way, you've never known what that looks like, how will we tell them about it? Will it just become mythology? And I really want to broaden this last slide or two and end on a note of hope. I really am grateful that you guys took time out of your weeknight to give literally space and time to these issues. But it's more than just this next frontier or crucible for the environment and light pollution. It's more about how do we answer to future generations? Unlike climate change, where we're endowed to a lot of mitigating solutions because we missed turning it around fully when we could have. And now we're just trying to dull the impact. We still have time for this. So we need to be the elders the future deserves, and elders based on sustainable relational practices, not conquest and claims, because what we do today are going to set precedents for how low Earth orbit and Eurospace are going to be used for decades, if not centuries to come. And I want to end, this is my last slide. I'm coming out of a couple of months of seeing some results from our wonderful international collaborative team's work. And that includes the new International Astronomical Union Center for the Protection of the Skies, which is IAU-CPS. The deorbiting timescale from space has been reduced from 25 years to 5 years. There's a quiet movement afoot in the federal government to begin to centralize everything in the Office of Space Commerce. It turns out the military is far more worried about the situation than we thought they were, so they've become wonderful allies. And I'll leave you with this thought. Many of you may have noticed all the headlines on Mauna Kea for the last 10 years where astronomers were being pitted seemingly against Native Hawaiian community organizers and cultural practitioners. And it was pitched as a very binary us versus them fight by everyone. And it has been my privilege over the last 2 months to be part of a small group of people in the room as the new Mauna Kea Oversight Authority Board was established by the governor of Hawaii, an 11-member board, where they've decided the situation has gone on for decades. We are not leaving this problem for our children and grandchildren. We will be the generation that solves this. And we are going to solve it by putting relationships and the mauna, the mountain, in the middle. They've decided stewarding the environment rather than pitting individual constituents against each other is what will best honor the future of Hawaii and Hawaiians. And I have learned so much from them, and we will be learning from them as we similarly hope for a stewardship of shared environment in orbital space rather than astronomers versus cultural practitioners versus industry versus the military. So thank you very much, and I will stop here.
Thank you so much, Aparna. There are a couple questions that came in, and as we're chatting, please, for everybody, go ahead and like I said, either raise your hand and we can just call on you, or put your questions in the chat. So Christopher asked, and he asked that earlier, and I think you had addressed that already somewhat, but just in case, there's something else to add. He asked, you briefly touched on the amount of debris in low Earth orbit, and I know that a lot of planning for modern satellites goes into how safely deorbit aging devices, but how seriously are governments and other space agencies taking the need to clean up LEO devices that weren't made with effective and deorbit plans?
That's a great question. There's a lot of companies out there proposing orbital cleanup. Wonderful, but none of them have been shown to work convincingly yet. They may. But I think instead of having this such a happy-go-lucky approach to something that could be irrevocably altered for generations, we need to apply the precautionary principle, right? We need to see what are all the things that could happen and try to account for the things we know will happen, because there will be a lot of things that we can never predict that will happen. One of them, related to the debris aspect, is collisions. We really don't know how debris cascades will go. It's quite possible that as orbital space gets more crowded, a couple of collisions will lead to more collisions, and then the Kessler syndrome kicks in where it becomes this unavoidable cascade, and you make a wide range of debris fields, particles, right? Like you make a wide range of sizes in the debris field. Then course correcting for the space station and all the satellites up there gets much harder because when you are dodging thousands and thousands of little pieces, right? And possibly some of you who've gone to space centers and looked at the spacecraft that are returned from space, even the tiniest specks achieve major projectile velocity. I mean, they come back really beaten up, the spacecraft. So we really want to minimize the debris fields. So I think it's better to minimize the field. If somebody comes up with like great orbital cleanup solutions, that's wonderful. But let me piggyback on that question because I see one question on the effect on climate change. Simply burning them up in reentry is not a great solution because the metal oxides that have already been deposited are accelerating climate change. That research is now out, and that's the wrong way we want to be handling climate change. We want to decelerate climate change. And I'll again add one more thing to that. There's so many things all of us can think about off the top of our head, and we really don't know how it's going to go. For example, solar storms are unpredictable. And when the sun has a solar storm and there's an enormous influx of ionized particles into our atmosphere and ionosphere, our atmosphere expands, it puffs up. So low Earth orbit begins to get swept up in this solar storm expanding atmosphere. And that's why we saw an acceleration of debris during some of the solar storm events last fall and last summer. The atmosphere puffs up, the satellites are like, uh-oh, experiencing a little more drag here. And then some of them just fall out of the sky. So yeah.
And the beginning part of Eric's question, what effect will the space pollution have on reflecting the sun's rays?
I think, I mean, I guess if it's a question of, I mean, their reflectivity of the sun rays is the light pollution problem. But as far as will they change the way sunlight gets to us? Not so much. It's much more of an impact for other wavelengths, spoiling ground-based astronomy and infrared and other things. But as far as the reflection part, they won't impact the sunlight getting to us, but they're going to intertwine with a lot of solar physics and other aspects of physics. Like a lot of observatories have to go to space, like high energy or solar physics observatories. But as far as the actual sunlight getting to us, not much of an impact, but more the reflection of the sunlight is the problem. And we have to be careful that mitigating solutions at one wavelength don't become a problem at other wavelengths. That has become our leading challenge in the last year. It turns out all the coding they did and all the other stuff they did ended up throwing off observations at other frequencies.
Yeah, I didn't know that. I was happy to read that, I think a few months ago or maybe last year, about the coding that they've been putting on it. So that was yeah, that's terrible. George asked, centralizing regulation in the government is a good step. Are the activist organizations considering coming together to create a single voice to influence the regulators and industry players?
That's a great question. And in fact, I think the lack of regulation and international oversight has been strongly taken advantage of by industry. I don't blame them because they see space as this glittering field of opportunity, and they don't want to miss the opportunity while a lot of rules haven't come into place yet. So yes, that is going to be a journey. You see the state of the world today on the most simple things, and bringing all countries into alignment will be a journey. But starting at a smaller scale, even though the US will soon become one of many space actors, nevertheless, many countries look to the US's methodology, procedures, and protocols in the legal policy landscape, and centralizing in one branch of space, of the government, space traffic management, space situational awareness, which is a huge field with the military and a lot of industry, and centralizing the licensing, right? And making mitigation and environmental assessment a condition of licensing. One of the core of the current lawsuits, the early few got slapped down, but they're now in appeals. One of the early combination environmental groups and dark sky groups lawsuits is the applicability of NEPA to space. NEPA is the National Environmental Protection Act. NEPA should apply to space, but it doesn't because space is not legislated as an environment. It seems silly, I know, but there are roomfuls of lawyers who will argue against it. So the question then becomes, there's a lot of law we can immediately come to bear on space if it could be legislated as an environment and also as a human environment, which it will be soon. So I think having one at the domestic level, making mitigation and environmental assessment a condition of licensing, having a centralized agency, and I'm not free to say more today, but there's some significant movement in the last month on that front quietly at the regulatory government levels. And at the international level, the new CPS Center is that portal where we're bringing together countries and industry and writing software together, but also trying to leave the door open to industry because there's a lot of new industry and nation actors now, and not all of them want to cooperate. So leaving the door open is pretty important. We got a lot of countries to sign off on the Outer Space Treaty, and I think we can do it again. Believe me, it got very hairy on Mauna Kea, and we may think that's just one mountain, but it got very, very challenging. And if they could come together laughing and moving forward together, I think we can. And I really appreciate the kind words, by the way, and the thank you sign, the kind words in the chat. Yeah.
And we do have a couple more questions. I know we're a little after 8. Do you still have?
I'm happy to stay, and I don't want to eat up other people's evenings. I'm glad to stay. Yeah.
All right. Well, I will ask away. Let's see. John said, thanks so much for asking these questions and bringing them to the attention to the public. Are there studies on the near and long-term effects of space debris landing in the oceans?
Yeah. So not long term yet. Near term, yes, the pollution is rising. And like I said, there's been more studies now done on the upper atmosphere. But as far as, it's kind of like the plastics, right? At first, it was sort of like there were so little, we felt, oh, a satellite here, a satellite there, what's the big deal? But now it's numbering in the thousands. And keep in mind, they've shortened the deorbiting timescale, which was seen as a big win. It used to be satellite companies had 25 years to deorbit what they put up there. Most of them deorbited it sooner though. But now they've made it 5 years, which means that's a lot of satellites coming down soon now. So we don't have the longitudinal studies, and I'm hoping we won't have the reasons to conduct them. So yeah.
Have there, we already see some of the negative impacts of satellites and space debris. Have we already seen the negative impacts on animal and bird migration?
Oh, very much, very much. The migratory patterns of a lot have already been altered by light pollution and increasing like sky brightness. I will try to drop into chat. There was an article that just came out, and one of my dear colleagues is a co-author on that. It was a longitudinal 10-year citizen science project, which I see was one of the, and I'm going to drop first the IAU CPS Center because they really welcome community partnership, and some of the our field's best code writers are working on code called Trailblazer, which is kind of working on taking out satellite light pollution from astronomical images. But there's a lot of citizen science projects going for that, and one of the aspects of that is that it's not just the sky brightness from satellites, but the sky glow from ground-based light pollution has dramatically increased in the last decade, and it's had palpable palpable fallout for like birds, bees, migratory patterns. I mean, I learned so much marine life. We are really very sensitive to bright skies. I mean, just our circadian rhythms are very sensitive to even a slight brightening of background light at night while we're trying to sleep. That's just us. But many animals are very, very sensitive to that, very much so. Yeah.
Thank you.
Yeah. And let me find that paper. You'll hear me typing. I'm not answering emails. You will hear me typing because I'm going to be finding that email, but feel free to ask away while I'm looking for that.
Yeah, Natasha had a great question, which is, can we assign citizens, help? And if so, how?
Mhm. Yeah, so there's a number of citizen science projects, and I just want to say that we very much need you, and we are finding ways to be forward looking with partnering. Part of the ways we've reached people is through a lot of youth advocacy, right? This is the future that they will be inheriting. I'm putting the press release announcement from this big paper. And this was published in Science, which is a great magazine and scientific peer reviewed. But in the first 4 days after this, it literally had 2,000 media pieces written about it. This is a great example of citizen science. And I just want to say we need you. The CPS Center has a good forward-facing portal. The folks that I work with, which is through my National Professional Society, we're developing a citizen science branch and also a youth core branch. There's so many young people who want to be involved, but we have to walk a delicate razor's edge with that, because the fact is that a lot of people 25 and younger, they've only known crisis and they're burned out. They feel like everything's in crisis: the planet, the oceans, economic system, democracies. So the resounding call we've heard through listening sessions with younger people is present this as something we can be involved in and make a change with. Like, otherwise we just kind of roll over in a curled up ball of helplessness, but which is like everything else. So we want to, and it's true that this can still be turned around. It's not as far along as other things. Yeah.
Like we were talking before the talk, we have the opportunity now before we have the opportunity to learn from history and the mistakes that we've made in the past.
Yes, I mean,
Plastics is a
even the
great
history of, right, even the history of transportation and utilities, right? If we could just regulate space-based internet like a utility, I mean, we can learn a lot from the history of regulatory landscapes with utility companies, right? Phone companies, electricity, and also from the history of transportation, right? Until speed limits were put in on national highways, how did it go? Like, I mean, it's just, there's so much to learn in a way that's been, I feel, almost the glaring sort of Achilles heel of this situation, is that it's so interdisciplinary and interstitial. No one knows if it's their, if it's their arena to be getting involved in. But the coalitions are building now. People are realizing that this is kind of a big deal and we need to turn it around. Yeah.
That's great. I think this might be the last question. Dave asked, does a shorter deorbit period mean that many more launches to replace does a shorter deorbit period mean that many more launches to replace the deorbited satellites? Does that make for a double-edged sword?
Yeah, I think that's a great point indeed. yeah, if they come down quickly, we need to replace them quickly. Now, by the way, I think satellites take such a beating up there, especially during solar storms or collisions. I think we were looking at a shorter deorbit period anyway. And the more there are up there, the more collisions and injuries we're going to see. Yes and no. I think that everyone's kind of waiting to see how this economic model shakes out. Like, how many satellites do we need in each, like in LEO, low Earth orbital space, to really have this amazing latency, affordable broadband that's been promised for a few years? So everyone's waiting to see how it shakes out. And I have to tell you, although this is certainly not my own approach, I like to be more proactive. We have gotten back chatter from people who've rotated off Biden's science cabinet in the last few months that one of the reasons that the current administration hasn't jumped on this, because, I mean, this is really falls under Vice President Harris's oversight, right, through the National Space Council. We've done a briefing for them as well. Why haven't they jumped on this more? Well, I think they're kind of waiting to see. They feel a recession is coming and things are going to slow down. And they think that the economic setbacks are going to really slow down industry. So they feel like we've got so much on our hands, we'll just let the economic slow down industry. It is not my approach, but everything people are kind of waiting and seeing. And that applies for this question about how quickly will we need to replace satellites and so on. I can tell you, we've heard feedback from our international collaborators. It is still not affordable in much of the developing world. It's still 10 times the average local income. So we haven't quite gotten there yet, and they might get there with more satellites and see how that goes for 3 years. And then maybe they'll decide whether to put more up there, or just don't want to be left with a sky full of hardware. It's infrastructure that's not easily removed, so it's not quite like burning down Twitter, where the infrastructure was certainly had a physical presence, right? But a lot of it was a digital footprint. But this is really going to be a sky full of hardware, and where's that going to go? So yeah.
Thank you, Aparna. And I just wanted to mention, somebody had messaged just me directly, but asking if the recording can be viewed again, and it will be on our YouTube, our speaker series YouTube channel, which can be linked to, or rather the link can be found on our speaker series page on our website. So just wanted to mention that because it seemed everybody really enjoyed the talk, Aparna, and wants to see it again, and hopefully possibly share it and build on this awareness that you're building on and is so appreciated. And I think
Are we allowed to talk?
Oh, please, yeah. And I can stay a few
Yeah,
more
because
minutes.
I don't know how to use this Zoom thing, and I didn't know how to type this thing or anything.
Please.
Educator, and what I'm wondering is, you've got UC Berkeley, you've got Stanford, they've got global education departments, you've got your new STEM and STEAM standards, and when this thing begins to coalesce, there can be that major connection with the STEM standards, starting from K. If you want a new generation to come up, they need to be familiar with the terminology and these core concepts, and just get these top educators. Stanford's just a hot spot there to start integrating this language, so the children have the familiarity with the terminologies and concepts, which I so far have just been oblivious of, but kids will be fascinated with this. And right now, NOAA, has got this whole international global science contest going on for what can we do with a plastic thing, but in terms of solutions and high creativity, and these kids for, future school are so competitive now, any kind of contest like this, they just jump for it. So like sponsoring, large open-ended contests and things, and just really generating it through the the K-12 educational pathway there. And you've just got a hot spot right there with those top schools. If somehow your astronomers can take little visits, into the core of these ed departments, with the science curriculum and the cultural curriculum, I think you could do something fantastic here in California that will meld right in with the science standards and get some creative young postdoctorals working on, integrated study units and online units and just familiarity. And the kids will get it jumping. They'll be talking and their parents have to do homework helper. And you're going to get an awareness among the population, which I think is maybe part of what's not there. You've got the super cerebral area, with these elite area of interest and upper echelon global awareness. But I think to really get at grassroots, instead of waiting, as you say, till it's too late.
I know.
Positive educational roots there.
Yes, ma'am. Great points. It's very much on our mind. We haven't gotten to it because we're kind of a, volunteer force, but we are really starting to look around for private funding to fund people to develop a K through 12 curriculum, because teachers approach me all the time. They've woven in climate change into their teaching material and environmental justice. And I didn't get into all the aspects of environmental justice, but that's the thing, light justice, environmental justice, and orbital space. And they're like, where's your 2-pager? And I'm like, so yeah, we need those materials. And after all, it's young people's future here, and they care. They really care. And I agree. I think a combination of bottom up grassroots advocacy, as well as institutional pressures, top down, is the way to go. So yes, I completely agree. And thank you.
I don't know. I probably can't volunteer at this point because I'm like an extended caretaker right now for my brother with advanced Parkinson's, migrating north and south, commuting from Whittier up to Santa Rosa here 30 times in the last 3 years, just insanity. But I just think someone, Stanford alumni, walking into the ed department, because those kids are always looking for good doctoral topics.
I know. No, I really agree. And I think we've had fingers and toes in so many realms, but we're growing in numbers now, and I think it's a great idea. And thank you for unmuting yourself. I know people are starting to leave, but is there anyone else who'd like to thank you again? Anyone else wanted to weigh in, or just unmuting is fine. I know it can be hard to find the chat function. Just feel free to unmute, please.
I would have chimed in with my voice, but Stephanie was doing such a good job reading through the questions. I didn't want to interrupt her.
But it's interesting to hear people's voices. I don't know why. Just a human thing.
No, and it's important. We're a community here. And yeah.
Let's hear the other guys. I'm curious. Nope. Oh, well.
Some people are shyer than me.
Yeah.
No, but she has such a beautiful voice and such a wonderful flow of information. But
yes, Aparna, you have a very calming voice. It's very soothing.
I really appreciate that.
Important subjects, but it's still delivered in this soothing, calming way that makes us all feel like, we can work together to help with this.
Thank you so much. My students often tease me about my late night DJ voice, radio DJ voice. And I often tell them, is that why you fall asleep in class? Because I can become a little more, loud if you need me to, but my natural state is this, I think, soporific voice. So it's, I'm like, that would explain people nodding off in my basement lecture hall.
I love that late night DJ voice. That's well, thank you. I know we kept you way over the 8 o'clock time frame. Thank you for sticking around to answer questions. It's always a fun group that gathers here, and lots of great discussion and questions. And Thank you so much for bringing this topic to light. It's definitely shed a lot of awareness, and I'm happy to thank you for letting us record it. It's definitely will be shared. And thank you all for joining us, and have a wonderful rest of your evening. Aparna, I think you haven't even eaten dinner yet, so hopefully you get to eat
Yeah, I thought I
dinner.
would wander out and check on my son here. But I am so grateful. I want to amplify the gratitude. Stephanie, Dave, thank you for the invitation. Our collaboration will continue. Let's go camping at RFO and stay up half the night talking about this stuff and brainstorming next steps, right? Andy, it's great to see you, and also really appreciate my family, my in-laws, mom and dad. Great to have you here, and great to be among all the friends and collaborators here. The journey in advocacy will continue.
I just want to thank you on the part of global humanity. You are a gift to humanity. Know that there is a person like you out there concerned with the future of our entire Earth sky and profound sky. The Earth is grateful. The Earth thanks you.
I'm so grateful to hear those words, but really it is a privilege to be in a position to advocate for the voices that are often missed. So
Yeah.
it is a great honor, and I am grateful for your kind words, truly. And thank you everyone for being here, and you will see me at RFO. I'm often up there with my family hiking, and I mean to circle back soon with USF students. So yeah.
Wonderful.
Looking forward to it.
Yeah. Take care.
Thank you. Thank you, everybody.
Bye-bye.
Thank you, Aparna.
Bye.
Thank you very much.
Bye.
Bye.